Okay, thank you very much. So, yeah, my talk is about awareness growth and belief revision. And basically, it's about this as a problem for Bayesianism. So I'll just remind you at the outset of these two commitments that many people take to be central to Bayesianism. We're thinking of models in which partial beliefs should be representable by a probability function, and models in which learning happens by conditioning, either Bayesian conditioning or some generalization. And in such models, uncertainty has a particular representation. So agents have probabilistic credences about any proposition will have some P of A. And when they're certain, they assign probability 1, and uncertainty is just captured by non-extremal probabilities. And then all changes of belief take place through a belief revision process of updating. So this involves learning. In the Bayesian learning case, it involves learning that a proposition is true. And in a Jeffrey updating case, it involves learning some probability for the evidential proposition. So uncertainty in general relies on having prior probabilities, priors for the probability you're going to be updating, priors for the evidential proposition, and so on. And the issue that I'm interested in is if we take these Bayesian models as a kind of total representation of an agent's epistemic life, then this is very unrealistic. So it's nothing like what happens in many of our ordinary cases. So I moved to Sweden last year, and when I did, I had lots of prosaic experiences that involved completely new possibilities, like opening up the drawer in my sublet and finding a smörkniv, which is like a small juniper carved wooden butter knife that Swedes use specifically for butter. Okay, I had no idea they used these things. It seems odd to try and force this into a Bayesian model. I just didn't know about the possibility. Or at least that's the intuition that I want to explore here. Similarly, it's not the case that a lot of scientific activity fits this model. So famously, the problem of new hypotheses is difficult to fit in. So if we consider a circumstance in which a theory is being introduced for the first time, like general relativity, it has a number of features which are difficult to fit into a Bayesian model. So the first is that it doesn't seem realistic that physicists who'd never heard of it before had some prior for it. Similarly, it's unclear that they would have had priors for evidential relations between the theory and past bits of evidence that they already knew, and so on. So this is the general field of things that I'm exploring in this talk. And the diagnosis that I'm interested in is that our uncertainty contains both known unknowns, which Bayesianism does well at capturing, for which we have priors, and unknown unknowns, completely new possibilities, which we can't reasonably be said to have had prior attitudes about. And this talks about those unknown unknowns. And I'm interested in what constraints rationality puts on belief changes when we become aware of and then later learn about new possibilities. So I like Bayesianism. I'm saying it's a good theory in its natural domain. I'm looking for a way of augmenting it. So the way I'm going to be playing in this particular talk is as follows. So Bayesian agents will have an initial state representing their awareness and their belief, represented by a Boolean algebra of propositions, which I'll denote omega, and a probability function p. And new possibilities are just propositions x, which are not in that omega. And so p of x is undefined. So mathematically, the aim of the game is to find a way of extending p onto a new algebra, which contains all the old stuff plus the new propositions. And philosophically, the task is to find some plausible rationality constraints on doing that. So what I'm interested in this talk is a partial answer to this challenge called reverse Bayesianism that was developed by the economists Carney and Vieira. And it tells you how to extend your beliefs, how to go from a probability function you currently have to a new one on the new possibilities, partly. And Anna Matani in a recent paper has raised a challenge for it that's related to some kind of philosophy of language type concerns, and that's what I'm going to be resolving in this talk. I'm not going to provide a kind of bottom-up defense of reverse Bayesianism, but you'll see that the reason for that is that Matani's challenge, while it raises some interesting questions, it doesn't really focus on reverse Bayesianism. So here's the plan. I'll introduce you a little bit more to what reverse Bayesianism actually says. I'll then talk about Matani's cases and introduce my proposed solution, which has to do with fixing a criterion of identifying propositions across this change of awareness context. And then finally, I'll just explore a little more how we choose those identity criteria. So to start off with, consider this example about the weather. A person called Naledi is considering tomorrow's weather. Being South African, she's aware of just two possible weather states, rain and sun. But having just moved to Sweden, she becomes aware of a third kind of weather, snow. And so her awareness state grows from the two propositions represented by the partition rain and sun to the three propositions rain, sun, and snow. So suppose that Naledi initially thought that rain and sun were equally likely. The question we're interested in is how should her beliefs change now that she is aware of the possibility of snow? So note that she's not learning any evidence about whether it's likely to snow. She just becomes aware that snow is a possibility. So what's going on here is that initially for Naledi, rain and sun were mutually exclusive and exhaustive possibilities. So their disjunction was the tautology. She assigned them equal probabilities, and she just had no probability defined on snow because she was unaware of it. Later, she alters the structure of her awareness space in such a way that now rain, sun, and snow together exhaust the space of possibility. Rain or sun is merely contingent for her. So afterwards, it seems like what should happen is that her probabilities assigned to rain and sun should now be less than 1, and some probability mass must be taken from these to be allocated to snow, to this new possibility that she becomes aware of. So reverse Bayesianism at a first pass is an answer to this question of how Naledi should take from rain and sun to give to snow. And what it says is that if all that happened is that the agent became aware of new possibilities, then there are no direct constraints on the probability to be assigned to snow, but there is a constraint on the probabilities of these old familiar propositions. And roughly speaking, what reverse Bayesianism says is that the ratio between rain and sun shouldn't change. And this is justified basically by a principle of conservative belief change. If you can leave something as it was, do so. Another kind of intuitive thing to think about is maybe a kind of reversibility principle. So what's happened here is just awareness change. And we want to imagine that maybe Naledi will become aware of it while learning that it won't snow. And it seems like then her belief shouldn't change. We want to kind of recover the initial beliefs. And preserving this ratio will be one way of doing that. So the formal machinery looks like this. Possibilities or propositions, they're going to be denoted with these capital letters like X or capital words like rain, and they'll be collected in sets curly X. The space of possibilities are going to be Boolean algebras, which are structured sets. I'll denote them omega, and they'll all be based on a set like curly X, ordered by an implication relation. The top element, when it's important, I'm going to be talking about different algebras. I'll denote V of X, sometimes with a top symbol. And what awareness growth does is that it takes agents from an awareness state omega to some omega plus, which is larger. So belief states are probabilities. As I said, normal belief revision takes you from some P to a Q defined on the same state on omega, whereas belief extension takes you from a P to some P plus, which is defined on the new wider algebra, omega plus. And what reverse Bayesianism says in the construction that I'm using, which comes from Richard Bradley's book, it says that when an agent undergoes awareness growth, so when new possibilities are added, their belief state should be rigidly extended to the new possibilities space. And what a rigid extension is the following. So for any P on omega, a corresponding P plus on omega plus is a rigid extension of that P to the wider space, if and only if for all propositions in the original set of propositions, if you take the extended probability, you look at the probability it assigns to X conditional on the old top element, that should be the same as the probability that the old probability function representing the initial beliefs assigned to it. Okay, and this will get you that intuitive preservation of ratios of familiar probabilities that I introduced the idea with in the kinds of cases where you want it. Okay, so this is broadly speaking the theory that I'm interested in exploring. And so here's how it works in the weather case. So Naledi started out with these two propositions, rain and sun. She then learned about the possibility of snow. And rigidly extending her probabilities would require that the new probability assigned to rain, conditional on the old top element, which was the disjunction of rain and snow, should be the same as rain. Okay, and then it'll say nothing about the probability assigned to snow except what comes out of this constraint. All right, so here's the problem that Anna Matani has introduced for this theory. She tells a story called The Other Tenant, and here's how it works. She says, suppose you're at your friend Bob's flat, which he shares with his landlord. So you know Bob's a tenant there. You know that there's only one landlord. The landlord lives in this flat. And in the morning, you hear some singing coming from the shower, and you're trying to work out who the singer is. And at this point, there are two possibilities, which we'll represent with these two propositions. The first is that the landlord is the singer, and the second is that Bob is the singer. Now, Matani says, you also know another thing. You know that Bob is a tenant in the flat, and so you have a credence in this proposition tenant, that the singer is a tenant in the flat. Now, given your state of awareness, your credence in Bob and tenant are going to be the same because they're equivalent for you. So now what Matani does is she says, well, what if somehow you become aware of the new possibility that there could be another tenant? And so you come to consider this proposition other, that the singer is another tenant. And so now what's happened crucially is that tenant is a kind of super category that covers both Bob and other as possibilities, right? It's moved up a level. And the challenge to reverse Bayesianism comes from considering this proposition tenant before and after the awareness change and looking at what reverse Bayesianism tells you to do with that proposition. So here's the issue. It's that both tenant and Bob are possibilities you were aware of before, and you previously assigned them equal credence because they were equivalent to you, so they both got 0.5. And reverse Bayesianism says that credences assigned to possibilities that you were aware of should remain in the same proportion after the awareness growth. So tenant and Bob have to remain in the same proportion, which means they have to get the same credence. And so now, because of the structure, because other entails tenant and Bob and other are disjoint, you basically have to rule out other. As soon as you become aware of the possibility of the other tenant, reverse Bayesianism tells you you have to set its probability to 0. And that just seems to be ruining everything. Now you can't learn about it. It seems to be ruling out precisely the thing it's meant to account for, which is the growth in your awareness, the fact that you're going to assign some credal mass to it. So Matani says this shows that something's gone wrong with reverse Bayesianism. Okay, so that's the challenge that I'm going to try and resolve here. And basically, my diagnosis of it is I guess that there's something funny going on with this proposition tenant, the fact that we have these two labels that seem to pick out the same possibility, Bob and tenant. So Matani in her paper actually just says they are two different propositions, but I'm going to avoid that. I want to just call them labels for the moment. And what's happening is that these labels, which previously labeled the same thing, come apart as your awareness grows. And that rigid extension principle just assumed that it would be obvious which propositions were new and which were old, and tenant is the kind of tricky case. Okay, so no surprise, I guess that's the whole point of the case. So the goal is to find a way of identifying what propositions are across changes of awareness, even when labels are changing in this way. And the reason I'm interested in this problem is because I think it reveals something about the structure of awareness change, which then turns out to be helpful in solving some other problems. So the modeling strategy that I took here is basically, I looked at the algebraic structure. So I thought about this space of possibilities as a Boolean algebra in the sense of a complemented distributive lattice. And what we see in this case is that when awareness changes, there are some things intuitively which are preserved. There are sort of propositions which appear in the new algebra, which were in the old one. But then there are features that don't get preserved, such as complementation relations. And because of some structure being lost, I'm going to look at algebraic objects with less structure than a full Boolean algebra and try to preserve that more limited set of structural relations. So what we want to do is relate this old algebra to the new in a way that helps to track our intuition that some propositions are still there, while also tracking the fact that the complementation structure has changed. So we're looking for a mapping. Because I'm thinking only about awareness growth here, new possibilities, the map's going to be injective. I want it to be an identity criterion, and so what I want to look for is a structure-preserving one-to-one map. So I'm looking for an embedding. I want to embed the old algebra into this new wider space. And the structure that I'm interested in is I'm going to preserve the lattice operations, the meet and join operations, but not the complementation relations, because what we saw there is that when you have what's called an expansion of awareness, when you add a new possibility into what you previously thought was a partition, you lose that complementation structure, the top element changes, And so it's not the full Boolean algebra that we're trying to embed. We're trying to embed a more limited lattice structure. So here's the recipe for modeling this. The initial awareness state is a Boolean algebra omega built on the set X. And after their awareness grows, they have some new awareness state, omega plus, built on a set Y. And for the moment, we won't say anything about the relationship between curly X and curly Y, because we're going to do that via the embedding. So we're going to embed omega into omega plus, and that one-to-one association of propositions in omega with propositions in omega plus is what's going to get us the old propositions being in the new algebra. And it turns out that just being careful about this illuminates what's happened in this case of Matani's. So here's the case again. And the first thing we need to decide at the beginning is we just have to clarify how many propositions there are in the initial setup. Are there 3, landlord, tenant, and Bob, or are there only 2? And tenant and Bob are the same proposition. So within a standard modeling framework where you're using a Boolean algebra of this sort, there just have to be only 2. Tenant and Bob have different senses. What we're drawing on here is that there's a kind of intuitively different meaning to those labels. But the case is trading here on something that we can't model in this framework. In a Boolean algebra, things have to have a unique complement. So landlord can't have 2 complements. Tenant and Bob algebraically have to be the same object here. So one option could be to say, all right, that's a failure of the framework. We need a much richer framework to model this case. But I don't actually think that's true. So I'm going to insist that there were only 2 propositions, and I'm going to claim that we can just resolve what was happening in the case in this framework that has only this expressive power. So here's the algebraic structure. So before, the way that I'm analyzing it, we had 2 propositions, which I'll call L and TB in capitals. Though there were only 2, they were mutually exclusive. And then afterwards, we gained, at the bottom level, we gained a third atom, which is this other. And now what's happened is that there's just ambiguity. There are 2 plausible embeddings. We could either map that old TB over to the small b, to Bob, and associate it with the person, or we could map it up to small t and associate it with this category of being a tenant. So this ambiguity is interesting. It really has nothing to do with reverse Bayesianism, though. It's just a feature of the case that she's described and the use of these labels. And so we just have to choose between these 2. So we can either embed into the left there. That's the option where you choose to map the old TB onto Bob, or you embed into this right, slightly more distorted looking algebra. And then once you've chosen the embedding, I claim, you can think about how you should be extending your beliefs. But the prior question is just this identification of propositions. So in order to do the extension of beliefs, we would need to update the definition of reverse Bayesianism, this rigid extension principle. So I'm just going to slot into the definition that you need to pick a criterion of propositional identity, a lattice embedding, H. And then the thing that reverse Bayesianism, that rigid extension is going to tell you to do is to look for the image of the proposition, what it gets mapped to under the embedding, and that the probability of that thing conditional on what you map the old top element onto, that is what needs to equal the old probability assigned to X. All right, so we can now apply this to the 2 options that we have. So this is the first embedding. This is the embedding where you took the old tenant Bob and you map it onto Bob, the person, in the wider algebra. So recall that initially, you assigned equal probability to landlord and to tenant Bob, so they got 50-50. So what happens when you rigidly extend under this embedding is that you are told that your conditional probability of B given L or B is equal to the old probability you assigned to TB. So that's the thing that gets 0.5 probability. You do the same thing with L. And now, even though these are conditional, because it's such a simple algebra, you just have enough information. So you can fill in the whole algebra. And what it tells you to do is that the unconditional probabilities basically have to be 0.5 minus some amount each, and you take away equally from the 2 of them, and then you give that amount over to other. So that's kind of an intuitive thing to imagine doing. You found out that there was a third person. You previously associated 50-50 with the landlord and Bob. And now what you do is you just take away from them equally and you assign whatever amount it is to the other. So this will allow you, for instance, to assign a third, a third, a third, if you think that that's the likely amount. Now, on the second embedding, what happens is that you map the old TB over to this T, to the category of tenant, the proposition tenant. So that's the thing that gets 0.5, and so does landlord. So now you're saying it's equally likely that it's any tenant or the landlord. And so once you fill in the rest of the algebra, what it tells you is that, well, the probability for Bob and other has to add up to tenant, obviously, but that's the only constraint on Bob or other. So you have to be taking probability only from Bob in order to give it to the other on this second embedding. Right. So where does this get us? Just doing this much gets us the following. We don't ever get into the situation Matani thought was a problem for reverse Bayesianism. So we're never forced to assign tenant and Bob the same probability. We're never forced to give 0 automatically to the other. And that's because embeddings are one-to-one mappings. And so you just can't map tenant Bob onto both tenant and Bob. I think it was just the informal way of describing the case that made that seem like a plausible option. So the sense in which tenant Bob is tenant and is Bob is just that there are these two embeddings. That's my claim. So reverse Bayesianism looks fine. The interesting action now is, well, we have these two options. How do we pick one? How do we choose which is the right option? So that's the final section here. And it seems to me just less sensible to do the thing where you take the previous 0.5 and you give it to this new category of tenant. So you say, I previously thought, when I thought it was just Bob who was a tenant, I thought there was 0.5 likely that he was the singer. Now that I know there are two tenants, I'm still going to insist that tenant overall, that gets 0.5, and those two guys have to divide that number up. Right, so I just think it's hard to start off with. It's hard to figure out why you would do that. And Matani agrees. I mean, she says in the paper, given that there might be two tenants, it's natural to suppose that your credence in tenant as a category should increase relative to landlord. So what we're looking for now is a systematic account of why we should choose this in this case and how we can extend that to other cases. So I'm going to start with another case. So here's a structurally similar case that Matani gives. Imagine I'm holding a 10p coin, a UK 10p coin, and I'm going to flip it. And you think the coin's fair. So when you consider heads and tails, you assign them equal credence. Now, if you know 10p coins, you know that on many of them on the back side, there's an engraving of a lion. So you also consider this possibility that the face of the coin after it's been tossed will show a lion. And so lion and tails for you are equivalent. You can see the structural similarity to the previous case. But now you become aware that some 10p coins don't have a lion on the tail side. They have a picture of Stonehenge on the tail side. And so your tails proposition, which was previously equivalent to lion, now tails has two sub-possibilities, lion and Stonehenge. And the question is, how should you adjust your credences in light of this new awareness? So again, we have these two options. Algebraically, things are similar. We have two embeddings that we could choose. But here it just seems even clearer what's going on, right? Like previously, we had two labels, tails and lion, for one of the propositions. And you can break this into two now, lion and Stonehenge. But you're tossing a coin. And so surely what you want to do is keep tails as having 0.5. It would be exceedingly odd to insist that it was the pictures on the coin that should be preserved in terms of the probabilistic judgments. The number of potential images just shouldn't change the probability. Okay, so the thing that's going on in this case is that structurally we're picking the other embedding, right? In the previous one, we didn't map onto the higher up category in the right-hand picture. We mapped onto the lower down new proposition in the left-hand picture. So I think it's clear that what's happening here intuitively is that those probabilities are coming from the chances that we associate with tossing coins. And those chances derive from, the symmetry of the coin. They have nothing to do with the image that's on the coin. And so they kind of attach to this heads, tails set of labels. And so my suggestion is, when we're extending beliefs to new algebras, we want to do so in a way which respects, in this case, the chance structure that determines these credences. So the embedding should be the embedding which preserves this reason that was the reason that you assigned the probabilities you had to begin with. Okay, and in this case, the reason is that there were chances. The chances are about the sides of the coin as sort of physical sides. They don't have anything to do with the labels. And so the image on the coin is irrelevant. So to generalize this, the suggestion is that we should be looking for reasons why the beliefs are structured as they are, and looking for these embeddings, which are how we resolve questions of propositional identity across awareness change. And we want to do that in a way which allows us to carry over the reasons we have to the new algebra. So that at the agential level, I think that this corresponds to using what you know to fit the information, the new information that you've received into a belief state in a way that is coherent. Okay, that's just the probabilistic part, but that preserves some of the reasoning that you had before. So in the other tenant case, I think we can make use of this. It just requires a bit more work. So initially, the agent assigned equal probability to the landlord and to tenant Bob. And so what we should do now is we should look for the reasons why they might have done so. Now, so often equiprobability judgments of this sort are due to a kind of principle of indifference reasoning. And so let's assume that that was part of what was going on here and try to identify how we can use that information. So principle of indifference reasoning requires identifying outcomes which are going to be judged equivalent given your state of information. So does that allow us to distinguish between these two potential labels? They're not different partitions, they're different labels for the partition, right? So the one is landlord Bob and the other is landlord tenant. And my claim is yes, it does, because landlord and Bob, the reason landlord is even in there, presumably in this story, is that you don't know who he is. Bob is your friend. But what you're doing is you're thinking about the two people who are in the house. Whereas landlord tenant is kind of thinking about the two roles in the legal agreement governing Bob's occupation of this apartment. And so it seems to me less plausible that the agent's initial reasoning attached itself to the legal roles rather than to the two individuals as people. So the embedding, which identifies propositions on the basis of personhood and the labels that track the people, is preferred to the embedding, which identifies propositions on the basis of these legal roles. And the justification for that, if it works, is because that was the reasoning under which the credences were assigned in the first place. And so that gets you this favored embedding, the first one, which assigned tenant Bob to Bob. Okay, so that's it. That's the end of my solution to this problem. So I think that this is an interesting problem. It's an interesting challenge. It turns out, in fact, that in many cases, there are these questions of identifying propositions when you have changes of awareness. Ultimately, it doesn't have much to do with reverse Bayesianism, but that's fine. I think that the interesting question is to figure out how to identify propositions across these changes. And what I've suggested is that we should track reasons. Now, the key thing that I want to do in future work is to try and develop what this means, how we can understand what people's reasons were. We often don't track that in models that are Bayesian models. So there is some work on reason structures, reasons-based rational choice theory that Dietrich and List have done that I'm interested in thinking about. Another thing that I've been looking at recently is work on belief as a question-sensitive attitude. And in this framework, all beliefs that we have implicitly regard a belief as an answer to a question, and a question is represented by a partition where the things in the partition are possible answers to the question. And so the thought is that if we keep track of what partition each belief is implicitly with reference to, that will give us some guidance here. But I haven't really worked out the details yet. So that's it. Thank you.